Hello, everybody. So today we're going to talk about the topic of coefficient of variation. Okay, now this calculation is done to estimate what the level of separation is between a series of values that we have in order to compare how much actually things are varying. Sometimes we think that there's a huge variation in the values between different amounts, but we don't realize that if we compare everything to each other, there's not that much level of separation, or sometimes it seems like they're all similar values, but they're not. And there's a huge amount of variation, and that's what we're going to find out. So the first thing we're going to do is define what coefficient of variation is. The first thing is that we need to know that it's the dispersion of a frequency distribution that is often presented as percentage. Okay, it is also defined as the ratio of the standard deviation to the mean. Now this sounds pretty fancy, it sounds very dictionary-like, and it is, but we're going to give you a quick example of what this means. The first thing that we need to show is what the formula is. So the formula is the coefficient of variation. It's actually very, very simple. It's just a simple division. The coefficient of deviation, okay? In which you divide, the coefficient of variation is the division between standard deviation divided by the mean. Okay? Now, to indicate what each one of these symbols are, the sigma, or the small caps sigma, is the standard deviation, which is the one on the top, okay? And then the mu letter, or the small caps mu that you have underneath, is the mean, which is pretty simple. So we're going to give out a couple of examples, okay? Now the first example we're going to give is probably the most simple one. Okay, in the first example we have two values. Okay, we have the value of, we're just going to call it the value of x, okay, which is database x. We're going to call it dbx. Okay, and we have database y. Okay, in the case of database x, we have values of 1, 2, and 3. Really, really direct. In the database y, we have the values of 101, 102, and 103. Now, the first thing that we must consider is that the average of these two, okay, is quite different. Okay, so let's check it out. Let's check out what this means. Average. For the first one, it's 2. And for the second one is 102. So the average between these two is completely separated. It's just way out there, right? But the standard deviation, well, I'm going to call it standard deviation, just so we can see the whole thing. Standard deviation, okay, on the other hand, looks quite different. Check this out. STDEV, standard deviation, for all these three values. Okay, the standard deviation is 1, and the standard deviation over here is also 1, which is kind of crazy, right? The average is completely different, but the standard deviation between these two is 1, because the separation between 1 and 2 is 1, the separation between 2 and 3 is 1, the separation between 101 and 102 is 1, and the separation between 102 and 103 is also 1. So, as you can see here, the standard deviation is 1. But the coefficient of variation, okay, you can call it like this, coef of bar. We're going to just make it smaller, so shorter so you guys can see it, is the division. Okay, we're going to divide the standard deviation by the average. So the standard deviation divided by 2 is basically just 0.5, and this one is 1 divided by 102. So the standard deviation is way, way smaller, and usually this is represented in percentage. So as you can see, the standard deviation for the first database is 50% because the amounts are way smaller. So the standard deviation is a lot bigger. But if the amounts have a higher number or higher quality, for them to have a higher coefficient of variation, they have to have a far larger separation. So the coefficient of variation in this case is less than 1%, which is quite small if you notice it. But of course, if you just observe the amounts, it doesn't seem like there's, you know, much of a difference, right? But in this case, the coefficient of variation shows us a completely different story. Okay, now we're going to do a different example. In this other example, we're going to show amounts from gas prices from different places around the world, okay? And we're going to look at gas prices from, to begin with, from the USA. Okay, now these are gas prices with different values. Okay, then we're going to take the ones from Japan, for example. And if you look at Japan, right, their amounts are huge. What's $2.35 is 1 gallon versus in Japan. Now these values are not completely true. They're placed here for the purpose of the calculation, right? But it's an estimate. So in Japan, 1 gallon is 533,450 yen. And then it goes on from there between 533 all the way up to 612,000. You know, and in this case, the lowest one is 2.35 and the highest one is 2.7, right? So let's calculate the average first. The average, okay, from this is going to be, let's see, $2.53 for 1 gallon. And in this case, for Japan, the average, okay, is going to be 584,606 yen for 1 gallon. Okay, now the standard deviation, let's look at what it says. This is where it gets really interesting. Okay, let's calculate the standard deviation for these values. Okay, let's see, in the case of the USA, the standard deviation is 0.13464769. And in the case of Japan, it's a whole different story. It's 32,283.6715. That's a huge standard deviation difference, you know, between the two. It's massive. But when we calculate the coefficient of variation, it's a completely different story. Check this out. We're going to divide the standard deviation by the average, and we get this should not be currency. This should be percentage. 5.33% difference. Okay, and if we do this with Japan, let's see what we get. We get a 5.52. So the coefficient of variation is not really that much, even though, you know, the amounts are hugely different, you know, but taking into consideration, of course, that we're talking about different currencies, the way they work and the way they function is completely different because of the large amounts or the very low amounts, like in the case of the US, right? But we can observe the differences that are important to notice in regards to the standard deviation. This is the deviation in comparison to its value. So it's 0.13 because the US is basically single digits, 2.35. And in the case of this is, you know, 5 digits, 32,000 in comparison to the few hundreds of thousands of yen that you get for $1, that you have to pay for 1 gallon of gas, right? So these two things are basically the coefficient of variation is basically comparing apples to apples, you know, comparing two things that are similar to each other, and that's what we get. So that's it. That's basically it for the coefficient of variation. In case you have any comments or questions, please drop me a message. Thanks.